So I'm John. I'm going to piss everybody in this room off at least once. At least once. And that's not to say that I'm trying to do that, right? I'm not trying to be difficult here. But I do think that we need to really start thinking about things a lot more than we have been, thinking about them differently. I'm a scientist. I run Ecdysis Foundation. It's a nonprofit. I'm also a farmer, rancher, beekeeper. And so we're going to talk a little bit about the data that we're generating, as well as some of the personal journeys in terms of science and how we're running it in order to help innovate our food system. I was down in Florida with our team. We visit agriculture with a big A. So we'll talk a little more about that. But I was on citrus was where we were working down in Florida. And we all know the identity of Florida is that orange, right? But what a lot of us don't know is that over the last 20 years, we've lost 96% of orange production in Florida. It's almost a dead industry. They think that it's related to a disease, but if you really want to know the answer to what's killing the orange trees, you're going to have to look a little closer in the mirror. The trees that are left all have, or many of them have, antibiotics that are being injected into the trunks to keep them alive. Chemotherapy, right? And you'll also notice the habitat in which these trees are being grown. Right there. I was talking with one of the conventional producers, and he said, John, the tree roots are anemic. They just aren't growing the way that they used to grow. And I explained to him, well, we're meeting producers. We're meeting producers that are growing vegetation from trunk to trunk. And they're reversing this. They're bringing dead orchards back to life. And he said, if that's true, growing vegetation from trunk to trunk, if that's true, then that flies in the face of everything that we're being told from the universities and from the citrus industry. And I asked him, how's all that advice working? And he thought about it for a second, and he said, yeah, you're right. They're not looking out for us little guys. I think that question that we're being faced with now is one that all of us need to be answering. How's it working? How's the status quo taking care of us? There's a problem. It's not soybeans. It's how we grow our soybeans, right? It's not cash grains. It's that agriculture has become far too simplified, all right? In an ecosystem, we have a biodiverse ecosystem, right? And that biology is wonderful because it does things. It supports the productivity of that ecosystem. And when you take that biodiversity out of the ecosystem and plant a single species, be it brome grass or be it corn or soybeans or wheat here in Spokane, then you eliminate all of the biodiversity that has supported the productivity, managed pests, regulated these different communities, and you have to replace it. You have to replace it with a jug. And it doesn't matter what it says on the side of that jug. It can say regenerative. It can say organic. But these chemical fertilizers and pesticides are doing one thing, and that's replacing what biodiversity used to do for you for free. We have to change this, okay? We have to change this because there's unintended consequences. Neonicotinoids. Have you guys heard of these, folks? Neonics, these are insecticides. So corn, soybeans, wheat seeds, these things don't come pink, green, blue, and purple, right? We treat them. And that treatment is intended to be taken up by the developing plant so that it defends that plant from early season herbivory. The problem is that the insecticides on these are terribly effective at killing insects. So each corn seed that's planted has about the equivalent of enough insecticide to kill 164,000 bees. The problem is that these neonicotinoids are not staying put. Okay? They're getting into, because only 3% of that chemical is actually taken up by the developing plant. The rest gets into the soil. It gets into the water. These are highly water soluble. It gets into plants that were never treated to begin with. A friend of mine, she lives in Montana, she said, we've got something weird going on with our deer. She said that 70% of the hunter-killed deer in her county had these jaw deformities. And 70% of the male deer ended up having genital deformities. And she wanted to know whether or not neonicotinoids might be correlated with some of these fitness responses that she was seeing in their animals. We put Elise on this. This was her master's thesis. Within a few weeks, this was one of the top cited papers, or like top 1% of all science ever written in terms of social media impact. Not bad for a master's student. This study will never be repeated again. It was terribly difficult. What we did is we took captive bred deer and we administered neonicotinoids to them in their water. And then we studied the impacts of that. We looked at all kinds of different tissues, right? Blood and milk and liver and brain. Spleens, the quantity of neonicotinoid, in this case imidacloprid, that was found in the spleen of the animal was correlated with these fitness responses better than any other organ or tissue that we tested. The dead fawns ended up having significantly more imidacloprid in their spleens. Moreover, the amount of neonic in their spleens was correlated with reduced fawn body weight, fawn organ weights. They were smaller. That makes sense, right? Smaller animals have smaller organs. Thyroid hormone levels. It's disrupting their hormones. Anybody in your life, in your family right now, have hyperthyroidism? There is in mine. Fawn jawbone lengths, that sounds familiar. Activity levels, they were slower. What's a slow deer in the wild? Dead deer, yeah. I could take this slide and I could replace the word deer up there, fawns, with bees. I could replace it with people, humans. It looked pretty dang similar, I'll bet. It's time for us to connect the dots. It's time for us to wake up. Jon, that is what you were able to supply or generate under captive. You force-fed those deer. Of course you're going to see impacts, right? This is what we were able to experimentally generate in the laboratory using our deer. North Dakota sent us a few hundred hunter-killed deer from their spleens, and we tested those. The natural population has 3 times the amount of pesticide in their bodies that we were able to experimentally generate. You think this is disrupting food webs at this point? Yeah, I'll say. We tested a bunch of predators from North Dakota too. About 15 to 30% of those were positive for neonics. Folks, yeah, there's consequences. And we need to be brave enough to actually point these out. We have a responsibility to do this work. 30% of the land in Washington's planted with these chemicals. Yeah. Drinking the hotel water? Yeah. How on earth did this happen? How did we come so far? This is my road in South Dakota 2 years ago. dust storms as high. Every one of my staff members driving around the country has seen a dust storm of this magnitude, okay? This is normal again. We are back in the 1930s or worse. How did this happen? There's a lot of reasons, okay? Science is one of them. It was the land grant's mission to not be asleep on the job. This happened on my watch as a scientist, all right? Let's see. Science is fallible. It's gray, right? It's not black and white. We learned this in undergrad, right? Where science, it's the best thing we've got, all right? In order to try to assess, the reality of the world around us. It's a framework, okay? But we're always just one step away from, being disproven. And so understanding that gives opportunities. Science is not perfect. Science is gray. It is not black and white. And science is manipulated. All right. How is this done? It was formalized by the tobacco industry. Okay, you can read all about it. Naomi Oreskes is a really good, she's at Harvard. She does a really nice job. It's a thick book. But they also made a Netflix documentary that you guys can all watch. How does this look? All right. Well, as a corporation, I have an agenda, or anybody has an agenda, right? So, suddenly a study that comes out, right? A study comes out that says challenges your agenda. Well, you find problems. There is no perfect study. The perfect study has never been done, right? And so you find all of the reasons why it is broken. And then you discredit that study. It looks like bad science at that point, right? And then, okay, so if science is gray and it's not black and white, how do we make decisions using science? Well, you rely on a preponderance of evidence. We repeat the same study over and over again under different circumstances, and eventually, hopefully, there's a consilience of evidence that ends up presenting itself. And we can use that for decision making. So how do you get a preponderance of evidence? Costs money, doesn't it? Costs money. Who's got the deepest pockets in the room? Yeah, large corporations sure do. And so you fund the work that you want to see done. That doesn't mean that it's bad science. It just means that it's gone in the wrong direction. It's not meant to be seeking the truth. But then you have a noisy scientist. Oh, geez, they just won't shut up. Well, what do you do to that person? You eviscerate them publicly. You destroy them. You destroy their families. You destroy everybody that they care about. And then you put their corpse up on a stake. And nobody else asks that question again. That's science. It happens at land grants, happens at the USDA. Science is politicized. There I am, a little more hair back in those days. I was doing everything right. Top of the world. Well, by all the metrics of success that scientists assess themselves by, few people had better stats than I did. I had tons of people in the lab, grad students and postdocs coming out my ears. I had publications. I wrote my first book by the age of 30, 100 peer-reviewed papers at that time. Grants, millions in grants. The chain of command loved it. I was served on committees. I was an advisor to the EPA as well as the European Food Safety Authority. I met President Obama in the White House for being one of the top scientists in the country. And then we started asking the wrong questions. We started asking about these genetically modified crops. We started asking about neonics and what their implications were. We started asking, the farmers were coming out of the woodwork and they were saying that they were developing systems that were really functional. The ranchers were. But science, they were doing things that science said couldn't happen. And we started to use our science to try to investigate and see whether or not this was true. And everything changed. Everything changed at that point. How's it working? For all of my accolades and all of my experience, and I could drive from my house in South Dakota over to my folks' house in the Twin Cities, it wasn't getting better. All of my science wasn't helping this situation. Climates were still changing. Rural communities were still declining. People were sick. Farmers are sick. And I didn't have a good answer for how what I was doing was making things better. And so I quit. I quit noisy because the USDA tried to suppress some of our work. And front page of the Washington Post. I think we all have to ask that question. Is what we're doing really a part of the solution at this point? And then I decided to rethink how science was needed to be applied. If we were really going to innovate our food system, and the scientific infrastructure as it was being practiced right now was inhibiting that, then maybe we needed to rethink how science was going to be applied. What would that look like? What would that look like? So I bought the farm, literally. I decided step one was that if I wanted to help farmers, I was going to have to become one. I've never had to learn so much so fast. We bought an operating farm. We raise sheep, honeybees when they survive. Christina has a cut flower operation. We have an orchard, poultry, pigs, you name it. It's an integrated regenerative farm. And I decided that our scientific staff, everybody on our staff has to be help on the farm. They have to learn what this is like firsthand. That changed everything. It changed the questions we ask, and it changed how we ask them. It connected us. It connected us with the problems that we were supposed to be trying to solve. It wasn't an experiment farm, right? This is an operating farm. So in our opinion, science is desperately needed right now. I was in California orchards talking with an almond producer down there. It was a conventional almond producer, and I showed him the data from his pest management in this case. He looked at the data and he said, "Jon, I don't believe it. I don't believe it. I did everything I was supposed to do. I followed the best management practices that were laid out by the UC system and the almond board, and I sprayed 5 times last year. It cost me tens of thousands of dollars. And what you're trying to tell me is that the farmers right next to me, right, the neighbors, didn't spray their orchards at all, and they had the same low pest densities that I had. And I cannot believe that." And then I explained to him that it wasn't just that neighbor, that we replicated it on several farms around the region, and that there was a degree of precision and predictability here, and that all of them were experiencing those same results. And that got through to him. That moved the needle. That farmer ended up transitioning 110 acres to regenerative the first year, and then all 1,000 acres the next year after that. It's a huge amount of investment, and it was based on the science. Right now, there are farmers that you are going to learn about in this room that's going to be so controversial because they're doing things that you think can't happen. And it's so easy to dismiss that, to sweep it aside, these anecdotal success stories that may work on your farm, but it'll never work on mine, right? That's where science can play a really important role in this story. But it has to be done differently. It cannot be done on an experiment farm. Because step one is that the scientific community needs to understand that they were never meant to be the experts on farming or ranching. They were always meant to be servants. Farmers and ranchers are the experts. Science can be brought in to help scale and transfer this and understand the mechanisms that are underlying it. But when we separate those two communities, we fail. We fail. It has to be systems level. I was hired, I'm an entomologist. I was hired to be a soybean entomologist in eastern South Dakota. How the hell was I ever supposed to solve that problem? It was never an entomology problem to begin with. It was a soils problem. By siloing our different disciplines, we are, there's no way out. We're in a self-perpetuating rut. It has to cross ecoregions. It has to reflect real food systems that producers are developing, not something that is made behind a computer desk to get a good, sexy grant. And that's what this study became. The 1,000 Farms Initiative was meant to try to fill as rapidly as possible this gaping chasm of, does regenerative agriculture actually work on a national continental scale? Okay. What is it that our food system is really capable of in terms of solving planetary scale problems? Number one, we were trying to validate, does regenerative agriculture work no matter what you grow and where you grow it? Number two, farmers are developing successful systems. How are they getting there? Can we empirically tease out certain practices that seem to be really influential so that the next generation of farmers that want to adopt these practices don't have to go through the same hurdles that the initial early adopters had to go through? This is where we've been over the last couple of years. We've visited 1,300 farms. This is a home base, Ecdysis Blue Dasher Foundation. This is where we deploy our scientific teams from. In teams of 8 or 9 individuals, we fly them out to these different geographic clusters all over the country. You can see where we're headed next. Right down there. The empty spots. All right. We're trying to stress test this under different climatic situations so that we can understand what our perception of regenerative food systems really are. So far, we have replicated designs on 35 different food systems or cropping systems and at least 5 different livestock systems. Cattle is the one that I'm going to be talking about today. I just presented at the National Bison Foundation the other day, and so we got to dig into our bison data. We've got 40 different bison ranches that we got full systems data on. Each of those dots lands on a continuum, and we assign it a score in about 2 minutes. I can assign most ranches a score from being very conventional to being very regenerative. It's based on very simple, it has to be simple if we're going to get this to work. How many animal units did you put out there? How often did you move them? How long did it rest? Did you use any parasiticides? Those are not meant to replace the art of ranching, okay? This is just meant to be a start. Then the ranchers come in and they explain to us how they are adapting this system in order to make it work for them. But I give these, so we're able to give these a pretty accurate score. This is published, it's free, open to the public. On each of those dots, we're doing a lot of things. We're measuring a lot. We're partnering up with the American Heart Association and Edacious to have the most comprehensive nutrient analysis of our food system that's ever been done. And the almonds, wheat, and apples that we sent to the PTFI, Periodic Table of Food Initiative, we generated 16,000 different phytochemicals from those yield samples, and we can relate that back to management. Really powerful data set. For beef, we finally have got a decent beef sample because, depends on if the animal comes from somewhere else and it goes somewhere else after it's been on your pasture, how do you relate the practices on that pasture with nutritional quality? And so we're going to start exploring that this year. Soil chemistry, physical properties. We're looking at carbon all the way down to 60 centimeters. Looking at water, how fast does it go in? How well do those soils hold on to it? Does it reduce your water use? But what really sets this study apart from anything else that's out there is that this is the largest bioinventory of our food system that's ever been conducted. I was talking with an Amish rancher out in New York, upstate New York. And he and his family were all out in the pasture with me, and we were sitting down, and I was explaining what everybody was doing because the team was milling about. Like, we're going to tell you all about the carbon that you got in your soils. He's like, okay. And then we're going to tell you about the water. He's like, yeah, great. And then I'm going to put a name on all of the bacterial and fungal species that are living in your soil. And his eyes got a little brighter. And I'm like, and then we're going to name all the insects and the plants and the birds that we're finding on your site. And every time I brought up a new organismal group, his eyes got a little brighter. And I had to ask him, I'm like, why did the biodiversity resonate so much with you? I mean, everybody's talking about carbon these days, right? And he's like, well, as part of our faith, humans, farmers, are meant to be stewards of life. And of all the scientific teams that are visiting our farm right now, nobody is telling us about that life right now. Regenerative farmers celebrate life. Fundamentally, that is what they do. We have about 14,000 species that have been identified from our food system so far. We're developing artificial intelligence algorithms in order to identify all of the insects, ecoacoustics to help our ornithological staffs extend their impacts. It's intense. And then we're also looking at the economics and the management on each of those different farms. Is it profitable? Does it work? This is some of the data on rangelands. So I've got croplands too, but I'm just going to talk about the rangelands for right now. How many of you have heard that cows are wrecking the planet? How many of you are tired of hearing about cows wrecking the planet? Yeah, me too. There's no doubt, right? I mean, cows fart and burp, and the greenhouse gases, they produce greenhouse gases, all right? About 4 to 14.5% of annual CO2 emission or equivalents are produced by cattle. How does managing those cattle affect that, though? And that's a really important question because, yeah, if you stick them all in a CAFO, guess what? Much, much different situation than when those animals live on the land itself. This is what we've got. These are the regenerative ranches. These are the conventional. What are the differences here? You increase the stocking density. You have high densities of animals, you move them frequently, and you let it rest. All right? That's what we're seeing in these different treatments. All right? Look at the difference in animal units per hectare. Look at the average grazing period. These are put out there and forgotten about. Okay? These are cross-fenced. This is the rest period. Based on our estimates, to attain what our land is capable of in terms of carbon sequestration and storage, we would need to increase the number of beef cattle by 2.5 times. That's different than the story you're hearing in the media, isn't it? The more animals that you would keep out on that ground, this is the scoring system. These are the most regenerative. These are the least. Your plant biomass, the forage, increases. Why does that? Thank you, sir. Why does that happen? Because as you graze that plant, it responds if you're doing it right. If you put them out there and forget about them, then you get an invasive species, you get a golf course, right? But when you put them out there and you move them at critical periods, then that plant community responds with additional growth. The biodiversity, the abundance of every single organismal group responds to how much plant diversity and a biomass is in a system. And this is what we have found in almost every single group that we've examined so far. 0 is the conventional ranches. The dots are the percent increase in all of these different organismal groups. Okay. We like life. Biodiversity is critical. We like it not just because we love species, but because these species do things. One of the things that they do is they take carbon dioxide out of the atmosphere and they put it down into the soil where it belongs. Current croplands store about 6.43 gigatons of carbon. Yeah, I don't know. Carbon. Everybody's, oh, carbon, carbon, carbon. Money, 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 right? I explain to farmers and ranchers, stop thinking about carbon. Grow life on your farm, and the carbon will take care of itself. Grow life. That is our jobs. Agriculture contributes. That's a part of that. Up to 30% of these emissions, and the U.S. Produces a lot of these as greenhouse gases. This is the total carbon that we were finding within the soil profile, down to roughly 60 centimeters deep. As you get more regenerative, as you get more life in that soil, you end up seeing carbon levels increasing. Such that if we were to devote most of the nation's rangelands to this style of management, it would store the equivalent of 5 years of our annual emissions while growing more life, while growing more healthy food, while protecting rural communities. You don't see that very often, do you? This is the best solution that I have seen in terms of carbon capture and storage. When they're talking about building a pipeline so that a foreign company can come and shoot carbon dioxide across the state of South Dakota, my state, to pump it into the ground, my God, that's criminal. For a fraction of what we could do with the land. And this is just the beginning, because when you start to heal the land, it works in ways that we could not ever have predicted. The best modelers out there could not predict. And it gives us other services as well. How am I doing on time? Where do you want me to start or stop? 15 minutes? I can do that. We're going to talk about dung, and we're going to talk about bees. You've all been waiting for the big old picture of poop. That's always the highlight. All right. Dung is important. If you don't believe me, ask an Australian. They introduced cattle into Australia without the dung insect community, and they ended up having so many flies and pasture fouling that it almost shut the beef industry down there until they introduced the bugs. It's really important for managing pests, because the pests cycle within the pat and reinfect the animals, and then it also it turns out that cows don't like to eat where they've just taken a dump. We did not take this pat and throw it in the air and shoot it with a shotgun, although that would be fun. Those holes are from insects. Okay. Dung beetles are a keystone species, because when they make those holes, and they're the only ones that are big enough to do that, they make a highway system for the rest of the insect community to be able to come in and break that pat down. And the speed at which that happens is absolutely critical to your pasture's functioning. All right? We think that it contributes, at least at one point, 40 years ago when this was first put out there, about $380 million a year. My guess is it's a lot more than that in today's speak. So we decided to try to update these numbers. To do this, we went out and we collected a bunch of fresh steamers. We brought them into the lab, froze them to kill anything that was living in them, weighed them out into 1 kilogram packets, and then put them out into the field. Some of them were caged to prevent insects from getting there, and the rest of them were allowed, the insect community to kind of hit their thing. This was Jacob Pachenka's work. And then we collected these up and weighed them to see how fast they would degrade over 42 days. To get the bugs out, we would bring them back to the farm, where we would put them into these coffee cans or cylinders, and then we'd warm them up. This was a very smelly job, okay? Very smelly experiment. As that pat warms up, The insects that live in it are like, oh my God, get me out of here. And they go down where we collect them into the receptacle on the bottom. And that allowed us to capture which insects are actually living in a pat. Because dung beetles are just the tip of the iceberg. Only 13 out of the 200 species were dung beetles. The rest of the insects are actually really important in monitoring or measuring, reducing those pats. What we find is that when we use these regenerative and conventional scoring systems, we can actually see how many species of insects are living within those pats. Those insects do things. They break it down. So the insects significantly increase the rate. These are very complicated graphs, and I do apologize for that. But essentially, when the insects are not allowed near those pats, it takes them a lot longer to break down. And what was so interesting is that we see this hockey stick, right? If I didn't put a linear graph on there, it would be a hockey stick. And what that means is that once that pat hits the ground, the clock's ticking. And if you don't get insects to eat that right away, colonize that pat, then it's going to last there a lot longer. And then we find, this one we're still waiting on final acceptance on, but the revisions are in, is that the number of pats on regenerative ranches ends up being substantially lower. And this is despite having a lot more animals on that piece of ground. Pasture fouling is less. The other issue, ivermec. Ivermectins are really good at killing insects and other things. They're a very effective nematicide. Most of the beef cattle in the United States are treated with this. The problem with it is that it has a very high half-life, and most of it comes out in the turds. And so it actually kills about 98% of the insects that are found in the dung. There's some theories that dung beetles and other dung-inhabiting insects are actually attracted to those pats that have insecticide in them. So it becomes this sort of bait and switch sort of a situation where they become a sink for dung beetles if you're using these porons. The question is how does management affect that? The more ivermectin that we were finding in these pats, we were finding that predators, a really important indicator of communities' vitality and function, ended up being reduced. And when we looked at management, we found, this is the fecal parasites, this is coccidia, we've got other ones as well that followed similar patterns, is that in almost, in the regenerative, the ones where they were keeping them tight, moving them frequently, letting it rest, had lower parasite loads than the ones that were treated with ivermec and grazed conventionally. Good management is how you combat pests. Because if you're using a pesticide, then you better invest in pesticide companies because you're going to be buying a whole lot more of it. It's an addiction. The more you use, the more you need. This is Tia's master's thesis. She wanted to know whether good management could help save the honeybees because the honeybees are dying right now. What we found is that floral abundance, when you start to manage this way, floral abundance goes through the roof on these ranches, all right, when you manage regeneratively. Bees need flowers. They like flowers. And what we find is that on these regenerative ranches, you end up seeing greater hive weight gain. You see they're more reproductive, and pests like varroa mites end up being reduced. And so you end up seeing these cascading effects on ecosystem services and functions that we could take advantage of as agriculturalists. Pesticides, fertilizers, the more you need, or more you use, the more you need. Who wins in an addiction scenario? It's not the addict. It's the guys pushing the drugs. Don't be a drug pusher. And that's not saying that you should never use medicine on your animals, okay? We use them for spot treatments on our own sheep flock, okay? I get it. You have to do that sometimes. But let's start with good management. Change the system. So how do you do this? How do you manage your pest problems without pesticides? Well, first off, you have to get off of the drugs. Then you adopt high intensity grazing, frequent movement of animals, and when you start to integrate herds, a monoculture that I was railing against at the beginning of this talk also applies to cattle. If the only animal that you are grazing out there is beef, then you have a monoculture, okay? Start thinking about how to integrate in other animals into your system. And the scientific community needs to be looking at this really hard right now. We were in blueberries in North Carolina. It was hot. I was on soil probes that day, so I was the one digging. It was an organic blueberry production system out there. It was a farm, and an old gentleman was there, and he was sitting on his rocking chair watching the show. The guy drives in, and I'm like, oh, I thought you were closed today. And the farmer's like, no, I let him come in. It's okay. He likes to pick the blueberries or whatever. By the time we were done sampling that orchard, the whole orchard was filled, right, with people, families with kids that were picking the blueberries. And I got finished sampling, and I walked over. He's like, John, come over here. And I sat next to him. And he said, I have to tell you something. And so I leaned a little closer. And he said, John, it's not about the money. Take care of your community, and the money will come. That's something that we're losing right now in a very greedy system. A very greedy system. As part of this study, I asked the croppers, are you experiencing any health impacts? Things in your families and yourself. These are all autoimmune diseases, allergies, asthma, anxiety. These are the rates that they had within our croppers. Then I looked at the national averages. Okay. This was not just farmers, this is everybody. We have a 200% increase in our farmers in depression. Asthma doubled. All right. Then I asked them about Parkinson's, and I asked them about cancer. This was their answers. We're killing our farmers. We're killing our farmers for corporate greed. These farmers are borrowing $850,000 a year to make $50,000, and they stopped asking the question, "Where's the other $800,000 going?" And it's going to large corporations that are milking our farming communities dry. And I'm sorry, I used to think we could do it a little better, and that would be good enough, and it's not. As scientists, as a scientific community, we have a responsibility to stand up and defend these people that we were meant to be helping. When did we forget? I thought the data was going to be the most important thing that we generated as part of the 1,000 Farm study. And it is. The data is really important. But it's more than that. This is wild blueberry farmers out in Del and Marie. They're in their 80s. And they have been working in wild blueberry production up in Maine for their entire lives. And they've risked everything. Every year they go out there and they risk everything because they believe in this, right? And they work hard their whole lives. And they've been fighting their whole lives against this swell of industrialization that threatens to take away small farms from their communities. And here they are at the end of their lives, and they want to know that somebody gives a shit, that it matters, that it won't just be forgotten. And in drives this caravan of 3 crappy minivans and spills out these enthusiastic scientists that think that this is the coolest farm that they've ever seen. And I didn't understand how important it was just for the farming community to feel seen, to feel heard, and that was part of my job. That's different. That's a different style of science than the one that's informing global food policies right now. This is my regenerative definition now. Regenerative farmers grow smaller and better, not bigger and simpler. They're growing food. They're not growing a commodity that they ship on a railway car to a CAFO in Nebraska or off to an international, on an international train market, right? Human feet touch every acre of their soil. We were driving by, one of my scientists, we were driving by his house. He lives in Litchfield, and he stopped the car and he pointed at a soybean field and he said, "John, that field was tilled. It was sprayed with herbicides. It was planted with a neonic and a fungicide. It was sprayed again. It had pesticides were flown on. It was harvested. It was tilled. It was sprayed again. Human feet haven't touched that piece of ground." That ain't farming, folks. That's mining. We need farmers. Really bad. What's changed? Gosh, John. I mean, I love the sound of this regenerative ag thing, but I'm kind of locked in. I've got this system, right? I mean, I've got the equipment, everything is dialed in. What's it going to cost me to change that? I think that's the wrong question. And I think more and more farmers in this country are understanding that that's the wrong question. What's it going to cost you not to change? It's going to cost you your farm. It's going to cost you your family, maybe a grandkid or two. Is that worth it? Wasn't for me. Wasn't for me. My parents have 9 grandkids. 4 of them have severe autism. My own kids. I've got 3. One has diabetes. One has autoimmune diseases. The other one, the youngest, she's got autoimmune diseases. And when we bring her to the doctor, the medicines just don't work anymore. This isn't okay. The science has become industrialized. Science has become industrialized, just like our farming communities have. And this has to change too. I implore the scientists in this room to connect with the people that are changing things in their communities, to support them. The last thing that we need is another armchair ecologist that is mining other people's data without ever and sending their grad students out to collect the data and not experiencing and getting dirt under their fingernails. That's the last thing that we need anymore. We need people to get out of their comfort zones and remember why they got into this to begin with. Because it ain't about putting a bunch of students through a puppy mill so that you can increase your citation factors. Okay. This is grassroots. We receive donations to get this done. So every farm costs us about $7,500 to measure, and we give it all away for free to the farmers and to the community. If you want to put your farm into the mix, scan the QR code, spread the word. We need your help. And that is what I got.
What an impressive way to start this program. A couple things. You can hang out here for a second?
Yeah.
A couple things. I want to just go over the order of the day. We've got 3 speakers lined up, as I'm sure you know. After each speaker, we're going to do some questions and answers. We will end the day with a panel discussion with all 3 presenters and some local producers. Please don't save your questions till then. There's going to be a lot of questions coming up. So now's a perfect time. We got microphones running around. If you have questions, now's the time to ask them of Jon. Yeah.
Oop. Oop. Right. Yes.
John, thank you. This is the second time I've got
Hey, Keith, will you hold on just one
You
second?
got-
Thank you. We also have some door prizes that we're going to be handing out. And our first go round of tickets that we got were not nearly enough for the great crowd that we have. We have about 170 people here in seats right now, and at least 50 people online that have been watching this live. So it's a really popular one. I have some more tickets that while we're asking questions, I'll go around and just make sure that you get your door prize ticket, and we'll do something right after this meeting, and then for the rest of the forum too. Sorry.
Yes,
No
Keith.
worries. Thank you. John, great presentation once again. Appreciate your time. From a systems theory standpoint, we realize that everything is interconnected,
Yeah.
right? And so when we look at systems, and the current system we're in right now is very driven from a monopolistic political course.
Yeah.
When we look at a system and try to make it inflect, where do we find the inflection point that's actually going to make the most change at mass, at scale, right? There's a lot of great people doing some really good things on small scale, but if we really want to make an impact, it's got to happen at scale. But with the current monopolistic
Yeah. It's really
financial
hard.
political system, where do we make change?
It's, and I don't want to be all Pollyanna, but I think that this is the answer. Regenerative agriculture connects farmers and all of us with the natural world, with families, and with communities. And I think that that's really where this has to start. Okay. When I interview, like when we talk to regenerative farmers, it's oftentimes those that, the ones that go this route, it's oftentimes the females in that family that drive the operation in that direction because they're prioritizing other things than simply economic profitability. And that doesn't mean that profitability isn't important. It's just one currency. And we need a lot of different currencies. We focus so much on this monopolistic, greed motivated food system. And I do not think that late stage capitalism applies to this. I think that we have to be thinking local first. Take care of our communities and the money's going to come.
John, I just want to say thank you. Thank you. And
Thank
keep
you.
it up.
Oh, geez. Yeah. Thanks to the farmers. They're the ones that are doing this. And yeah, talk about the saviors of the planet. What an honor.
Excellent presentation. Thank you. Thank you for being here, and thanks for all for organizing this. We hear your comments. Your last story, so to speak, talked about the soybean field and the different layers of chemicals that are being applied to it and their effect. Okay. But I'd like to contrast that to semi-arid West, 12 inches of rainfall a year, range habitat, sagebrushy, bunch grass. We're not spraying a lot of chemicals.
Right.
How do you take kind of the message you want to bring and, apply it to the 12
Right.
inches of rainfall range
Yeah.
situation?
So regenerative rangelands have a much different approach to understanding what regenerative management is than croplands, number one. Okay, some of the same principles apply, and you guys are going to hear more of that from Alejandro. But I think that we are right now, as we get into new climatic zones, as we get into different scenarios, we have to adjust what we think of as regenerative production. And what it is based on is the outcomes of increased carbon storage, the outcomes of increased life, and then tailor those, our specifications according to those. The other thing that's so important is that, like I said before, this is just the beginning, and the science is never meant to replace the art of ranching, because regenerative management of livestock is a philosophy more than a strict set of rules. All right. And so that's where the interaction with these really progressive ranchers is going to become really important in trying to define this.
I want to ask about the motivation behind the people that change. So
Yeah.
can you talk about any research, any stories about what is it that's driving the
Yeah.
people to make the change? besides
Yes.
passion?
We actually have that as part of our grower survey at the end. What is your motivators for change? Which is, I'm gonna brag about our staff a little bit, because so we have a grower survey. We've done administered this every year since the start, and it goes out to, I mean, every producer in the study. So 1,300 producers. Normally, when you do a grower survey, you get like 5-10% response and you're jumping up and down, right? That's something else. We get 75% response rates out of our producers because of the relationships that we've been able to develop with these people. We've met them. One of the questions that we ask is, what motivates you? Conventional producers. Okay, this is really interesting, actually. And normally I have a slide in here, but it's more crop focused. With conventional producers, it tends to be motivated by economic currencies, okay? Things like profitability or perceived profitability, perceived yields, things along those lines. With regenerative, profit is important, but also the mental and physical wellness of their families ends up having a higher or disproportionate number of respondents. What's really fascinating is that both conventional and regenerative both claim that soil health is one of their primary motivators. Even though those conventional producers, I mean, we can show them the data that it says that it's degrading their soils, they still believe in that. And they still believe that that's a primary motivator. Super interesting. At this point, this is no longer a practical or ecological question of whether or not regenerative agriculture is real or can happen. This is a sociological question of what are the mental barriers, because the practical and physical barriers, I think our data is showing that they don't exist. So this is becoming very much a grower behavior situation, and we need rural sociologists really badly right now. Yes, sir.
We've got one here.
Oh, I'm sorry. Yep.
I'm a beekeeper too.
Hey, all right.
I thought the varroa mites was interesting. I wondered if you could talk about how does the regenerative practice reduce varroa mites?
Yeah, varroa mites are just a symptom of sick bees. And so, yes, that is a perfect example of how science is manipulated. Because if you look at the scientific literature on this, pesticides, I mean, I watched this happen. The large corporations like Bayer and Syngenta ended up coming in and they defunded any pesticide research on a federal level. So that, and then they funded a whole bunch of varroa mite research to show that the varroa mites are what's killing the bees. And I'm like, on our own farm, we don't treat. We give them only honey. We don't feed. Our varroa mite levels are minimal most of the time, right? We just don't see these outbreaks. It's only when we end up seeing a pesticide incident that we see varroa mites have the leg up. Those bees get stressed. So I think that that's the answer to the varroa mites were never the problem. If they were the problem, we had carrying capacities or the economic thresholds for varroa mites for most of until 2008. Varroa mites, you could have 100 varroa mites per 100 bees. And then 08 comes in, neonics end up hitting the market. You get a lot of herbicide exposures, fungicide exposures. The threshold was reduced from 100 per 100 bees to 3 per 100 bees. And nobody connected the dots. I'm not saying varroa mites don't kill bees, but let's get to the root of the problem.
Good morning again. Thank you for your presentation. Just a question. You talked about, of course, the money will come, what have you. And there's a regeneration. It's going to be a process, and it's going to be a time involved. So on a rough estimate, considering that different farms would be starting at a different position in that, is there roughly an estimate where you could say the regen process takes 2 years, 3 years, 4 years, because you're going to be looking at that bottom economic line. I don't care. It presses heavy on on every producer's mind,
Sure.
whether you're a rancher or farmer. So what in your study, so kind of a rough estimate of how long it takes you to go through the regen process to fully establish that and get your ecosystem, whether it's farming or ranching, whatever, back into a shape that will be productive.
That transition question's a huge one. So we have data. We have not analyzed it yet because we're still in the middle of the process where we revisit ranches and farms annually for the first 5 years of their existence or what their transition. And so we haven't been able to analyze that yet. I can anecdotally say we visited farms and ranches across the country at this point, including my own. There is something weird ecologically that happens, a bump at year 4 and year 7, where suddenly you see the farm starting to act differently. The productivity increases, and in my thought pattern, at least, that these are key periods of time for detoxification of the soils and getting the biodiversity at where it needs to be. And I have a feeling that that's going to tie in with this economic question. I'm not convinced or willing to say that you are going to lose money during your transition unless you're not doing it right. But I do think that we need to be thinking about that for sure. Pardon me? Yeah, there is. Well, so our economic analysis of croplands, which suggests that there is not a cost. We have not done the economics of the rangelands yet, but we're going to look real hard at that. And if it doesn't affect them, then what is it that they're doing that they are able to be profitable? And can we share that story? Yes, sir.
Yeah, John, I want to follow up on this sociological focus.
Yeah.
Because I agree with you. I think this is much more about sociology and how communities organize and how they support each other than anything. So as you look around your work around the country, and we explore how to scale this, are you seeing any examples of how communities within landscapes are sort of reinforcing and supporting themselves? So it's kind of like that protect the core kind of a deal, you know? And so, you know, out here in the West, we have a lot of great collaboratives and they're thinking about these things. But I think there's a strategy in how through community organizing that this could be advanced and supported more effectively. And I'm just curious with your 1,000 Farms project, if you're seeing examples of community organizing in certain areas that actually advances this change.
Spokane is one of the communities that we've worked with that self-organize. This has been one of the most exciting things for me to watch with this grassroots science is just that, is that these communities are starting to come together based on the 1,000 Farms initiative in some cases, right? Where the farmers have particular questions that they're interested in pursuing, and then they approach us and say, okay, if we get organized and we get 20 farms in this area to try something different, will you come out and put some numbers behind it? So, because RMA isn't going to cover us this year, you know, the risk management agency, the farm insurance. And so we'll come out, provide them with free data about this transition or this new practice. We've seen this happen time and again across the country right now. The farming communities are getting organized. Really exciting to see.
Hi, John. I just want to say great presentation.
Thanks.
And I had a question on transitioning.
Yeah.
And its effectiveness. Have you seen or do you see any scenarios where, I mean, I'm assuming all these farms are on a smaller scale where you have these small scale farms surrounded by big conventional farms and, you know, the transition might not always work. Is it always the right move for a small scale farm to transition to a regenerative farm? I imagine a large scale farm that surrounds something like that would just suck the biodiversity out.
Yeah. So number one is that these are not just small scale farms. And so that's an important thing. We're going to learn from Alejandro about a decent sized farm. What's it, like 1 million acres or something that you're running down there? Anyways, So how the other thing is, so we try to match each of these different food systems and ecoregions with the average for a particular area or for that particular food system. Number two, is it always a good idea? Somebody has to start it. And I'm not saying there isn't risk, but until somebody's brave enough to stand up and do something, then the status quo just isn't going to get us where we got to go. And so, yes, I think that people taking risks and developing systems that work, it all seems impossible until somebody does it.
So like in the areas that are dominated mostly by corn and soybeans,
Yeah.
and like the infrastructure is all focused around those two crops,
Yeah.
how do you connect the regenerative growers and their regenerative, more diverse crops to the profitable markets that will allow them to succeed?
Yeah, so a lot of this ends up being local community. So selling within your community is an important component of that. Getting premiums for your product, which sometimes are certified organic, or maybe it's heritage grains or something that has a higher value. We actually do see yields are significantly lower in regenerative. Profits are equivalent. And that's because the regenerative people, again, they don't have to be lower. These regenerative farmers are choosing to grow things that don't yield as much for other currencies. And so those are some of the things. The other thing is, if you're starting to grow, diversify your rotations or new animals in your ranch. Yeah, it seems like, good Lord, how are yeah, I know exactly where I'm going to sell my corn, beans, and beef, right? I know where that locker is. I know where the grain elevator is to sell that thing. And as we start to diversify out, I listened to a friend of mine, a farmer down in Georgia. His name is Will Harris, and he's like, where are you going to sell your oats? To me, that sounds like a business opportunity. And I'm like, yes, we need to be thinking outside of the box and developing these new markets. It can't just be, this is a big shift that we're talking about, okay? And it touches on so many different facets of society.
I had a question about so a lot of people are talking about the financial impacts of switching over to regenerative stuff. And I was just wondering if you guys had any data about your producers and if they were in debt or not. Because from what I see, ranchers and farmers who are not in debt have a easier time because it doesn't matter as much. Well, if we don't make as much money this year or for the next couple of years, that's okay because we don't have to pay the bank. So do you guys have any data on your producers and if they're in debt and stuff like that?
Debt load. So we have a lot of economic parameters. I do not believe that we've got debt load as one of our questions. We've got kind of a in and out on that particular field or ranch. We do have questions about, whether or not they're receiving subsidy payments and things like that. I can tell you on a personal level that most of our farming community is under crippling debt right now. Crippling debt. And the CAFO owners, the hog barns, are in some of the worst. The dairies are in some of the multi-generational debt. And that's one of the motivators, right? So our metrics of success have to change. For scientists, we have to change them. For farmers, our metrics of success have to change. For a long time, being a good farmer means bought the quarter next to me, right? I got bigger. And grandpa and dad were real good at that. And now we're sitting with a whole bunch of farmers that are farming, 1, 2, 3,000 acres. And the only way that they know how to do this, and they're seeing their kids are sick, and the only way that they know how to do this, though, is with cash grain. And so we're in the situation where actually one of the motivators is the legacy to past generations was a big motivator, disproportionate in our conventional producers, because they don't want to let their families down, right? If they're the ones that loses that farm or even that rented ground, then they look like a complete failure. So again, this gets back to that sociological element, doesn't it?
We got time for one more question.
All right. So my question is, how do I, as a land manager for an agency that doesn't directly ranch but manages a large swath of land that ranchers rent, how do I promote this to my ranchers?
Only give contracts to people that are willing to graze it well. I think we need to start getting hard on that. You guys, yeah, thank you. The other thing is form that community. You know, we've got around us, we've got a Soil Builders Coffee Club that give the producers that are trying things in our area an opportunity to work together. And they have. They built an interseeder together. There's plans online for our roller crimper that these farmers put together, right? It was a brilliant opportunity for community development. And then another thing is if you have a piece of that ground and you do have an innovative producer that's trying something different, then give them the reins, right? Adopt a system on a small area that you can then expand out. Don't bet the whole farm on it on year one, right? Try it out, make mistakes, and then move it forward from there. Thank you.
Let's give Jon a hand.